So who am I? I work for Big Industries, which is a consulting organization focused on Hadoop and big data, mainly Hadoop. It's a very popular solution for managing very large amounts of data. So to give it some perspective, I think in 1995 or something like that, Alta Vista started as a search engine. And for the first few years of operation, they had 4 servers. And with that, they were able to index the about 30 to 40% of the World Wide Web. And over time, that has grown. So Alta Vista has kind of faded away, but Google kind of took over from that. And the amount of data that they handle is phenomenal. It's an explosion of data. And it's something that a lot of the enterprise guys weren't, like IBM and Oracle and so on, weren't able to really respond to. So I think Amazon started a project, a NoSQL database project in 2007 called Dynamo, because they were being crushed under the cost of Oracle licensing. Because, okay, in 1995, when you're starting with 4 servers, it's quite manageable. But when it's scaling to multi-data center scale, with literally thousands of computers to handle the load, it's not cost effective, and that's where the enterprise vendors kind of fell down. So Hadoop was an initiative that was started by Yahoo. Yahoo is predominantly a marketing organization, really, more than a search organization, although they do have something to say there. And they were responding to the challenge of a white paper that had been posted on the internet by Google. So they wanted to build a large-scale parallel processing grid computing system that could store and process data on a vast scale. Really, the emphasis was on the scale of the data, the volume and the velocity of the data. I'm going to have a screen lock now. So what was I saying? Volume and velocity were really the concerns, and security was not really there in Hadoop, and in many of the other ones, many of the other similar technologies that came along at the time. I think of those technologies, they've either converged onto Hadoop, or they've gone away a bit on the whole. So Hadoop has really stood up as the one that's staying around for the long haul. It had some serious holes to begin with. I don't think it got real authentication until the end of 2009. So I think what happened was that Yahoo's security team did an audit of the product and said, this is not up to our corporate standards. So they implemented Kerberos as a kind of patch set on top of Hadoop in about 2009. It didn't really meet any of the basic criteria for data governance, which are confidentiality, integrity, and availability. So confidentiality of the data, assuring that it's not going to get exposed. Integrity, ensuring that it's not going to get corrupted, and availability, ensuring that it's available. Hadoop couldn't really address any of that. I think I've got a slide coming up. So it had multiple single points of failure. A single point of failure is, for example, a single component within the solution that is critical, and if it fails, the whole solution is taken out. So it had lots of them. It didn't have really authentication as such. It had a kind of I trust you authentication, attempted authentication, and authorization that could be easily spoofed as a result. No encryption of anything, and no real accounting trail of any kind. So that's what came to life in about 2009-10 when it broke in the media. So it was pretty flaky. Oh, come on. Excuse me. Right, here we are. I think the core proposition was pretty valuable, though, as did many other people at the time. They saw a huge opportunity to address the failings of the major system vendors like IBM to address these large-scale compute challenges at a good price, you know. Price reduction was one of the main drivers for building these systems, so it seems sensible to then put some commercial backing behind that and sort out some of the technical challenges that they were facing. So vendors like Cloudera and Hortonworks sprang up. Also MapR is another one, but they took a totally different approach. So what the two main guys, Cloudera and Hortonworks, do is they take the Apache, you know, open source goodness and wrap it up and package it and test it and indemnify it and add enterprise-ready features to it, including into the core of the solution, much like Red Hat or Ubuntu or some Canonical or someone like that does with Linux. So that's what they do, and I would say that multi-layer security is quite achievable in a Hadoop computing environment. So, you know, I think they plugged most of the holes. So this is what I was meaning by weak authentication. So if you run Hadoop in its default configuration, that is not with any kind of authentication whatsoever, in secure mode they call it, then basically you can spoof the system into saying that you're the root super user of the file system and recursively delete everything. So it's kind of pretty heavy impact, pretty severe impact. So it's kind of worth setting up security. And if you don't, bad things can happen. This is a screen that LinkedIn sometimes shows if you do naughty things to it. Okay, and as other people have mentioned this evening, the impact is quite severe financially as well. So these aren't penalty costs. This isn't the cost of the government fining them. This is the cost to the business of a data breach. And here are a few unfortunates that have been breached, and I believe that there may be more coming out of the woodwork soon. Yeah, Sony was a massive one. The US government, federal government, just got breached. eBay, yeah, lots. Target is another one, of course. So 3.8 million per breach. I've heard other statistics about breaches in banking, a bit higher in banking. So that's average across breaches, but I think it's a lot higher when it's a banking breach. Okay, so the main feature of Hadoop core to minimize the risk of abuse is Kerberos. Kerberos is an authentication protocol which has been integrated comprehensively across the solution. So implementing that is rather worthwhile and reasonably straightforward. There are some gotchas, of course. One, of course, is this. So that would be a Kerberos principle, and that would be to many technical users a perfectly acceptable one. It's not quite. Kerberos uses a three-part principle, not a two-part principle. So it's quite easy to exploit a two-part principle. So if you create a two-part principle HDFS at domain, you can address basically any cluster that's running on that domain. So that's not good. So you can map explicit principles, explicit mappings within Hadoop. Worth doing. It's a complex thing to set up, but it's reasonably straightforward. Kerberos is worth it. Okay, there are a number of additional components within Hadoop. One of the most popular is the Hive SQL engine, which is a SQL compliant interface into Hadoop. It runs on MapReduce and nowadays on Spark. And it gives you JDBC integration. So all of your reporting and visualization and charting applications can now talk to a Hadoop cluster directly with the data stored in the file system. It's quite an empowering feature, but it can also be a huge security hole. So for example, you can create user-defined functions much like you can in a database. but you create them as a Java archive and you upload them to the cluster. Obviously, that's a security risk. The enterprise vendors have been busy. They came up with Sentry. Sentry is a wrap around Hive and also Impala, which is an in-memory equivalent query engine. They've come up with a wrap around that called Sentry, which enables you to like whitelist and blacklist UDFs, create grant and revoke roles and privileges and all of that good stuff. So a lot more lockdown in a sensible and consistent way, much as any other enterprise database solution or data warehousing solution would be. Quite a good way to control access to the cluster as well. A note on versions, yeah, things change all the time. They're always finding holes and patching them. It's worth keeping up to date with patching, and that means using not your own homebrew Apache Hadoop, but going to an enterprise solution vendor and relying on them. Oh, not again. Excuse my computer. Yep. Okay, moving on. Not moving on. So we wanted to address availability. So we talked about availability being availability of the data as being a critical concern. So I think the core of Hadoop has high availability in most of the major features. So I talked briefly about the features, the file system. Yarn is the parallel processing grid enabling technology of Hadoop. That has high availability now. Hive is the SQL data warehouse interface. Again, that has high availability now too. And HBase is a no SQL. Well, latterly it does have SQL. It's a database, a distributed database that runs on top of Hadoop clusters. That also has high availability, has had it for a long time. Okay. DR, disaster recovery. What do you do when somebody does an RMR slash on your cluster and takes away all the data that was there? Well, I think in the core you have point-in-time snapshots. So you can take a snapshot of a path and dump it to disk, or to HDFS rather. The only drawback at the moment is the consistency is not guaranteed. So if you run a snapshot backup on point-in-time snap on a directory that's being written to then or being processed on, the processing is running on, then you may have some problems with consistency. So better to use your noggin and be sensible about it, and only do that on archival or cooler data directories. But it's worth it all the same. Yes, so offsite or site to site or cluster to cluster DR is also there, but they are vendor specific solutions, so they're not part of the core. I think in Cloudera Hadoop, it's the BDR solution, which is a payable extra, and in Hortonworks you've got I've forgot the name of it now. You've got another solution. I think it's something part of that Falcon solution. I can't remember now. Okay. My strength is more on the Cloudera side. Yes. So encryption. So encryption is another feature that's now in the core of Hadoop. Encryption of the data stored in the distributed file system. You can define encryption zones. The key management is externalized, which is good. And you can, with the vendors, you can also plug in key management servers, so you can have HSM integration, stuff like that as well, if you want that, or you need that. What else to say? Yeah, it's been developed with Intel's money, so it runs really nicely on Intel chipsets. Okay. Wire encryption. I think it's across everything, or at least most of the services have have SSL integrated, so RPC calls are encrypted, endpoints are encrypted, etc. Again, it's optional, and you have to turn it on, like nearly all of these features. But that's part of a professional setup. Yeah, for the strong encryption, you have to install special policy files across the cluster. Doesn't come as standard, so yeah, the automation tools that the vendors provide will help with that. But otherwise, you're going to be stuck with a weaker level of encryption, which is not great. Yeah. Accounting, yes. So the provenance of the data and metadata management and audit trails and all of that good stuff. There are solutions there. Navigator on Cloudera, and definitely, I'm sure it's Falcon now on Hortonworks, are the auditing solutions. So yeah, again, not part of the core solution, but if you're going to if you're an enterprise and you're planning on setting this up properly, then you're gonna have a paid support agreement, and you're going to get this stuff anyway. So it's there. Oh, it's Ranger. I do apologise. Ranger. Okay. Tokenization. So, yeah, what's tokenization? Tokenization is more for the granular record or field level privacy. So when you're talking about credit card numbers, social security numbers, bank account numbers, anything personally identifiable, any PII, you can typically tokenize that using there are third-party solutions that plug in really nicely to Hadoop that enable that. What can I say about them? They typically enable rekeying and all of that nice stuff really, really well, so also worth investigating. So if you need to really have a guaranteed level of very granular privacy down to user groups, analyst groups, whatever, tokenization is probably the way to go. Okay. So, completely my opinion, but I think there are some places, of course, where things could always be better. I think the setup of the security stuff is complex and it's time-consuming. It can always be better. It can always be simpler. A lot more of it could be automated than it is. SE Linux, yeah, there's like no support for it, or hardly any, across all the major distributions, which is a bit rubbish. So access control in terms of policy, declarative policy on resource access is not really there. You have a Nox. Nox is a sort of reverse proxy solution with kind of pluggable control modules. It's not really mature, but it's a step in the right direction. I think the concern is around applications, access to the network, access to operating system level functions like sendmail or whatever, that sort of stuff. How do you restrict that, especially when considering data science, which is more likely to be, calling out to Python or something from a MapReduce job, that sort of stuff. How do you lock that down? Okay. Yes, integration of a Hadoop cluster. Yeah, you can have a lot of conflicts there with established practices, best practices. Hadoop has its own set of demands, and they're not always compatible with corporate IT standards. So that can be problematic and quite difficult and careful. You need to navigate that quite carefully. It might involve some sign-off, accepting of certain risks. Who knows? Depending on the environment that it's going into. Typically it's things like remote access. A lot of the setup and deployment scripts that come bundled with these solutions, they require either a SSH with a password or keyless SSH access across the estate. A lot of companies don't like that. It's that kind of thing. So need to plan that. Yeah, so summary of what you've got in the core. Kerberos, you've got authorization, which is either based on the Unix groups on the boxes, which can be synchronized with an Active Directory or whatever. Or you can do an LDAP mapping, although not really recommended. I believe the best approach is, the preferred approach is Unix groups. Role-based access controls for Hive or Impala, which is kind of an overlay. Again, that can be integrated, I believe, to LDAP. HDFS encryption over the wire. You've got active passive failover built in for HDFS, Yarn, and HBase. So that means that you don't have to set up anything else like Linux high availability clustering or anything like that. And yeah, data integrity should be assured by the file system. It has a few controls there to assure that. So hopefully my screensaver won't lock in. Okay. Oh yes, what about Poodle, Heartbleed, Shell Shock, whatever. Yeah, I think that goes back to the first presentation this evening. You know, you need to have a proper response to security incidents. You need to have a proper patch management solution in place. You need to have a layered security model in place. You know, you need to tighten up your act. Basically, I think that's a big wake up. I mean, with a multi-layered security architecture, you might get away with it anyway. I mean, that you might have those vulnerabilities within your stack, but if there are other controls to protect against them, then you should be, in theory, all right. Beyond that, good governance should mean at least a meaningful response can be established. And also, if you work with a vendor-managed solution like Cloudera or Hortonworks, then they are very responsive and quick to respond to these 0 days. So defense in depth, just mentioned it. It is totally doable. MasterCard have a Hadoop cluster, and theirs is PCI DSS compliant, so it can be done. It got compliance cert rating in 2014. So secure data hubs are entirely achievable with some effort. Okay, that's me. I've done my slides.
Excellent.
Thank you. So if you have questions, feel free to shout them or ask me afterwards. I'll be around for a bit. Yes?
How about newer tools like Spark? Are they also
Yes.
integrated?
Yes. Well, Spark runs under Yarn. So Yarn has integration with Kerberos, and HDFS has integration with Kerberos. Since Spark is running under Yarn, it also has, it benefits from the security model of Hadoop. Yes. Mm-hmm.
Yeah, you present several tools for securing different aspects of Hadoop, but is there an overall security model that those things are implemented? One or more models, and or do they?
Yeah, so is there a lockdown script kind of benchmark security overview of the security architecture? I think the answer to that is not at the moment. So the the Center for Internet Security, CIS, they have a suite of benchmarks for different technologies like Windows and Red Hat Linux and iOS routers and stuff like that. They are working on a benchmark for Hadoop core, but they haven't got there yet. So in terms of, do you have a vendor-neutral, reliable way to lock down a cluster? Not at the moment. In terms of a high level, security strategy, I think each vendor has their own approach. So whilst there are some commonality and there are some, some good practices there, depending on which vendor you go with, you're going to get a slightly different story.
Good. Are the traditional security organizations, I'm thinking like a second, that give the certifications like CISSP, CISM, CISA, how are they keeping up with this? Because I see things moving very fast with Hadoop and all the other, the crazy names that are coming with Hadoop, Yarn, Spark, Pig, Zookeeper, et cetera, et cetera.
Well, I just did the CISSP certification, so I'm CISSP certified. I did that this year, and I can say there's nothing about Hadoop in there.
So they haven't really kept up with the big data stuff.
Their focus is more on the general ecosystem of infrastructure, and data management and data governance and people side. I wouldn't say that. But they don't have. They don't have anything at the moment covering NoSQL or grid computing, cloud even. So some way to go there maybe. Yep. Anybody else?
Can we run up here?
Okay.
Because we still have some.